salient features of molecular orbital theory. So, different features of molecular orbital theory. So, first point is molecular orbital. Molecular orbital theory is related to molecular orbitals which belongs to a molecule, and molecule is combination of atoms, right? So molecular orbital, first feature is definition of molecular orbital. Yes, we have done this. What is molecular orbital? Just write the definition. Tell me, what is molecular orbital? Who is this Hare Ram? What is molecular orbital? Molecular orbital is the region in space. Yes, anybody? Molecular orbital definition: region in space comprising nuclei of combining atoms. Okay, it is the region in space comprising nuclei of combining atoms where there is maximum probability of electron density. Okay, it is the region, this region in space comprising all the combining nuclei, okay, and where there is maximum probability of finding the electron density. That region in space is called molecular orbital. Okay, it is different from atomic orbital. Okay, atomic orbital is again the region in space around the nucleus, particular nucleus, where the probability of finding the electron is maximum, right? Now this is the first feature of molecular orbital theory, that what is molecular orbital. Okay, second, the combining atomic orbitals. Combining atomic orbitals have equal energy in case of homoatomic molecules or homonuclear molecules, and have comparable energies in case of heteronuclear molecules, right? Means combining atomic orbitals, they have equal energy. Homonuclear means when atoms are same. Homoatomic, diatomic, triatomic, tetraatomic, right? If they are homoatomic, means they have same atoms, right? Then they should have equal energy, all the atomic orbitals which are combining. Okay, and if they are different atoms in the molecule, like HCl, NO, CN, right? Then they have comparable energies. Means there should not be large difference in energies of the atomic orbitals which are going to combine with each other. This second feature, you got this point, that those atomic orbitals will combine, which have almost similar energy. That means energies of the atomic orbitals should be same or almost same. Okay, very good. Then third point, third feature is the number of molecular orbitals is equal to number of atomic orbitals participating in combination, like in diatomic, triatomic, right? Like say if we have 3 atomic orbital of one atom and 3 atomic orbital of the second atom. So how many molecular orbitals are formed? Tell me. So first feature, you know that molecular orbital is the region in space comprising all the nuclei where the probability of finding electron is maximum. Second is the combining atomic orbitals should have almost similar energy. And third is number of molecular orbitals is equal to the number of atomic orbitals participating, or we can say taking part in chemical combination. Very good, Ravi. If 3 atomic orbitals of one atom and 3 atomic orbitals of the other atom, they combine, then we get 6 molecular orbitals. Okay, the total number of atomic orbitals taking part in chemical combination is equal to the number of molecular orbitals. They remain same. If there is one atomic orbital combining with one atomic orbital, we get 2 molecular orbitals. That's it. So this is the third point. Third feature of molecular orbital theory. Now fourth, when 2 atomic orbitals combine according to we can write total according, is it visible? Yes. According to LCAO method, what would we get? Tell me. When 2 atomic orbitals combine according to LCAO, what is the full form of LCAO? Well, first tell me. What is the full form of? Yes, characteristics, features, characteristics, even you can call it as postulates. Yes, tell me. what do you mean by LCAO? Full form of LCAO. Very good, Abhay. Linear combination of atomic orbitals. So according to LCAO method or LCAO principle, you can write it as principle. Okay, it is a method or principle. When two atomic orbitals combine according to LCAO principle, they form two molecular orbitals. One is bonding molecular orbital and other one is anti-bonding molecular orbital. Means when they combine according to LCAO principle, first is addition of wave function, other is subtraction of wave function. Addition of wave function leads to bonding molecular orbital and subtraction of wave function leads to anti-bonding molecular orbital. When crust is over crust, that is bonding. When crust is over trough, that is anti-bonding. Crust over crust, trough over trough, that is called addition of wave function or constructive interference. Sometimes we use the word interference because they combine together, waves are combining, so that is called interference. Okay, that is constructive interference. If crust is over trough, that is called destructive interference. Okay, that I will share the video. Okay, you will watch that video also. First we will complete these features, characteristics. So according to LCO they combine and we get bonding and anti-bonding molecular orbital. Okay, fifth point. Yes, the bonding molecular orbital has higher energy or lower energy? Bonding molecular orbital has lower energy or higher energy? Tell me. Very good, Abhay, Anika, Ralam, Namita. Very good. They have lower energy. So bonding molecular orbital has lower energy, or we can say higher stability as compared to that of anti-bonding molecular orbitals. Okay? Okay. This is the fifth postulate. Now, the bonding molecular orbitals are denoted by the bonding. I can write now this like this. The bonding molecular orbital are denoted as or designated as sigma pi delta, and anti-bonding molecular orbitals are denoted as sigma star, pi star, delta star, okay, etc. Okay, so this is the sixth point. Now next 3 points are very important because they are related to structure of atom. Say atomic orbitals filling is just like atomic orbital fillings. See, when we have, I will quote some example and then I will write 3 points. because there are total 9 postulates. Okay, so tell me, if we have 1s and 2s, tell me which one will be filled first? Out of 1s and 2s, which one will be filled first? Yes, delta wala we will not study up to class 12th, but I let you know a bit about that. Okay, very good. 1s is filled first, then 2s. Why 1s is filled first, then 2s? Why? Ralam, Abhay, Mansi, Anika, Vadehi, Sakshi, tell me why? Because of energy. Because energy of 1s is lower than 2s. So, orbital with lower energy is filled first, and then of higher energy. What is the name of this principle? Oh my God, before my question you have given the answer. Ralam, great. Okay. So, and when electron pairing takes place, it is like this with opposite spin. When 2 electrons are filled in the same orbital, they should have opposite spin. What is the name of this principle? It is Pauli's exclusion principle. 1s, 2s, then 2p. 2p has 3 orbitals. So, first electron is like this. Second electron, that is in the different orbital. Third electron, that is also in the different orbital. And then pairing starts. So what is this principle? That pairing does not take place until and unless all the orbitals of similar energy are singly filled. It is Hund's rule. These 3 principles. Apo principle, Pauli's exclusion principle, and Hund's rule. They are applicable to molecular orbitals as well. A molecular orbital bonding or antibonding can accommodate. Is it visible? Yes, can accommodate maximum of 2 electrons with opposite spin. That is, what is this? Pauli's exclusion principle. Okay. Point number 8. Yes. Yes, point number 8. Molecular orbitals are filled in the order of increasing energies, in the order of increasing energies, starting with the orbitals lowest energy. Means orbital with lowest energy is filled first and then next one. That is Aufbau principle. Right? Now, point number 9. In molecular orbitals of equal energy. Yes, tell me. Orbitals of equal energy, a specific name is given to that. Those orbitals have given a specific name. What is that? Orbitals of equal energy. So, in molecular orbitals of equal energy, that is degenerate orbitals. Electron pairing starts only when all the orbitals are singly filled. That is called Hund's rule. So that means Pauli's exclusion principle, Aufbau principle, Hund's rule, all are applicable to molecular orbitals. Done? These are the 9 features, you can say characteristics, postulates, whatever you want to say, but these are features, characteristics, postulates of molecular orbital theory. You know, when we have 1s, 2s, 2px, 2py and 2pz, right? 1s, 2s, 2px, 2py, 2pz. Okay, how they form sigma bond or pi bond, that you will see in the video that I will share after the class. Okay, but keep in mind, when 1s combined with 1s, we get 2 molecular orbital. One is sigma 1s, other is sigma star 1s. Okay, when 2s combined with 2s, we get sigma 2s and sigma star 2s. When 2px combined with 2px, we get pi 2px and pi star 2px. Okay, when 2py combined with 2py, we get pi 2py and pi star 2py. When 2pz combined with 2pz, we get sigma 2pz, sigma star 2pz, because z-axis is taken as internuclear axis. That is most important point. You might ask question, why 2px and 2px will give pi, 2py give pi, but 2pz will give sigma. So that the answer is this. Z-axis, we could say only one axis is passing through the nuclei. Internuclear axis is one only. Okay, out of x, y, z. So if we consider z as the internuclear axis, then 2pz will form sigma and other will form pi. If x-axis is taken as internuclear axis, say very important thing, if x-axis is taken as internuclear axis, then 2px will give sigma 2px, sigma star 2px, other two will give pi. Okay, only one is head on, others are sideways. Up to nitrogen, order is means increasing order of energies. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, then it is pi 2px equal to pi 2p y, then sigma 2pz, then pi star 2px, pi star 2py, and then sigma star 2pz. This is the order of increasing energies. Order of increasing energies of molecular orbitals. Up to nitrogen, this is the order. And O2 onwards, O2, F2 and Na2, order is again sigma 1s, can I write? Yes. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Up to this it is same, but here sigma 2pz is before pi 2px and pi 2py. Only this is the change. Rest is same. So first of all, remember this thing. Up to nitrogen, pi 2px and pi 2py is of lower energy than sigma 2pz, and after N2 means O2, F2 and Na2, it means O2, F2, Na2, sigma 2pz is before pi 2px and pi 2py. So actually this is the order of energies of Bohr principle. Okay, for MOT, for molecular orbital theory, that you have to remember. 1s and 1s will give sigma 1s, sigma star 1s, 2s and 2s will give sigma 2s and sigma star 2s. It is very simple to remember because 1s is of lower energy than 2s and bonding is lower energy than antibonding. So this is a simple case. Okay. Up to means lithium 2, see. If you write for lithium 2, beryllium 2, boron 2, then carbon 2, or nitrogen 2, you will follow this order to fill the electrons. And for O2, F2 and Na2, when you fill electrons in them, you will follow this order. That means sigma 2pz is filled first and then pi 2px, pi 2py. They are degenerate orbitals. In this case, pi 2px and pi 2py are filled first and then sigma 2pz. Now, from this order, just write down the electronic configuration of lithium 2. In lithium 2, how many electrons are there? Tell me. Say for sigma and 1s and sigma star 1s, most of the time we write it as Kk because it is in the K shell, inner shell. Either you write sigma 1s, sigma star 1s, or you can write K. So let us take this first. So for lithium 2, lithium has how many electrons? Tell me. 2 has total 6 electrons. Start filling. Sigma 1s 2. Because each orbital can accommodate a maximum of 2 electrons. Sigma star 2s, sigma star 1s 2. Then sigma 2s 2. Complete. Any electron left? I think no electron left. Right? Total 6 electrons. All the 6 electrons are filled. So likewise write for, now you can write it as K sigma 2s2. Can I write it like this? Sigma 1s2 is K, sigma star 1s2 is also K shell. So you can write it like this as well. Okay, write for beryllium 2, B2, C2 and N2. Just write for that. So leave it here. Okay, today we have completed the features. Bye.